All right, well, thanks for sticking around. The second talk is a project update, what Venice shipped in the last year. And I'll be giving the talk. My name is Felix. I like to say that I'm the lead janitor because I love deleting code. I've been around for a while and I am not a cat. Um, this is my agenda for today. I'm going to give some stats about the project. I won't dwell on that too long, but just a few quick hitters there. And then, did I touch it? No, we're good. Um, and then I'm going to talk about what changed in Venice. Now, obviously, it's impossible to cover everything. It's a big team, and I'm going to be covering about a year of changes. But I'm splitting it into user-facing changes and then kind of operator-facing changes, which are improvements, I hope. So a few just general stats. We have this concept of stable release that we published a blog post about a year ago, along with our first um, and unfortunately last public stable release. And I'll get back to that in a second. But first, what does it mean when we call a release stable? It means that it passed our internal certification. Currently, this is a test suite that is outside of the continuous integration you see in open source. It's like kind of an extra round of beating up the system where we check for performance, chaos testing, we try to find longevity issues, that kind of stuff. And assuming certification passes, then we progress through many steps to ramp that release eventually to the whole site, right? So we have a staging environment, which is not really for us. It's more like for our internal users. But occasionally we discover issues there as well. And then we start ramping in production, which means we canary to one node of each cluster of a single region. And then at each of these stages, we ideally survive a load test, and we have a few other internal tools that help us assess the health of the system. Assuming that goes well, then we go to full cluster deployments of a single region, and eventually all clusters of all regions, which means the whole site, right? Now, if we got to the whole site and we haven't rolled back, then we call that a stable release. The last official stable release that we published about in open source was a year ago, almost to the day, like a year and 2 days ago, based on a commit from May 17th. But in reality, we've had a bunch of stable releases since then, right? We could say they're like unofficial stable releases because we didn't talk about them in public. In 2024 alone, we've had 10 site-wide releases. So admittedly, we need to be a bit more diligent about publicizing that work because it is kind of misleading to say that the last stable release was a year ago. Like I said, we've had a bunch other stable releases since then. As a matter of fact, I think the investment we've made into the system has allowed us to increase the velocity of releases that we've had. So the last 6 months, like I said, we did 10 site-wide releases. This is more than the 6 months prior. So things are trending in a good direction. And therefore, I'm going to use the opportunity of this talk to announce today the next official stable release, which will be based on tag 04263. And therefore, this talk is about the delta of changes between the stable release that we published about last year and the one that I'm going to talk about today. During that span of time, we've had just a bit more than 500 commits. That's about 1.3 commits per day, weekends included. And obviously, we can't cover all of that in a 30-minute talk. But I'll try to do my best to highlight some of the themes. We've had 34 unique contributors, including 14 new ones. A lot of them are sort of hit and run, just providing one commit, but we like it. Some of them are contributing to documentation. We had a commit about formal specification, which we love also. And some people are fixing up scripts. and some people are writing into the core of the code as well. So we welcome all of that. Just want to give a quick shout out to our power committers. We've got Surav, Nisarg, Jialin, and Sushant who committed the most during that year. Thank you. This is a breakdown of the main modules of the project. At the top, you got the 3 services that make up Venice: controller, router, server. And then we've got a bunch of client libraries. And you know, this gives you kind of just a brief sense of where a lot of the investment has gone in. So enough with the stats. Let's get into the meat of the presentation. So these are the user-facing changes. So those are sort of like the surface area, the APIs, stuff like that, right? The capabilities, let's say. So let's start with the write APIs. What is new here? Before I get to what is new, I just want to give a tiny bit of context. In Venice, we have a schema aware system. It's a strongly typed system, and the schemas are evolvable, right? So here is an example. This is not actually the schema definition language. It's kind of like pseudocode, pseudo schema, you could say. But this is just to give an example. Let's say your store has 2 value schemas where the version 2 schema adds a new field. All of these fields are optional, which means the value in each of these fields could be either null or whatever type the field is, meaning, you know, an integer, a string, or some other type. Now, under the hood, what Venice does for each of these value schema is it auto-generates what we call a write compute schema. Sometimes we call it a derived schema in the code. And essentially what that does is for each of the fields, it's going to say, well, not only can this field be null or an integer, it can also be a no-op. And this is how internally we encode updates going into the system, right? Because an update could avoid touching one of the fields, right? So it, for example, if I want to write to field 2, I may be nullifying the field 2, or I may be writing some string inside the field 2, but I may want field 1 to be a no-op. I don't want to touch it, right? So in the first iteration where we shipped support for updating data in Venice, like updating just a subset of fields, we built all of that stuff with the write compute schemas, but then we exposed the write compute schemas as the API to the user. We thought that was fine, and we've had many production use cases built on that. But the feedback we got from users is that it's not the most user-friendly, right? Because whenever you like register a new schema, then you have to ask Venice like, hey, what is the derived schema that I need to write with now? And there's all this back and forth, and it was just not the most productive workflow. So we've introduced some new write APIs that we think are easier to use. One of them is the update builder. So now there's a DSL that you can use to declare the updates you want to do to specific fields, or we also have another kind of operation supported here, which is collection merging, where you can add or remove elements from collections, and the backend takes care of doing the merging on your behalf. And none of these require fiddling with these like auto-generated write compute schemas. It's now an implementation detail hidden under the hood. We still support writing directly with the write compute schemas. There's no plan for now to deprecate this lower level method of writing into Venice, but we think the higher level API is just easier to use. Another one we did is the producer API, where now you can write to Venice from any service. You don't need to have a stream processor anymore. Now, if the use case is stream processing oriented to begin with, then it's totally fine to use a stream processor, of course. But we have use cases where they just want to write some data to Venice from their online application. And up to now, what they would need to do is like set up a Kafka topic to write into from their online app, then spin up like a pass-through a stream processing job that just is kind of a dummy job that takes from the Kafka topic and passes it to Venice. So all that scaffolding is no longer necessary for the simple use cases, right? Where the stream processor is not really useful. So this client, the producer client, supports all of our operations, put, delete, and update. The update uses the update builder API that I just mentioned, and it supports physical timestamps and logical timestamps, which is an advanced functionality of Venice. Another API, sort of in the same theme here, is when you push data from the grid using the push job, you can enable the incremental push mode, which means it's not going to create a new version of the data. It's going to write into the existing versions of the data set. And if you use the incremental push, you have the option of either writing full rows or updating just some of the columns of the row, right? So that was already there. But again, you had to make your input conform to one of the already existing write compute schemas, which was very constraining and made the offline job users' life harder. So now the push job is smarter, and it can look at the input schema of the job and figure out if the content of the input is any valid subset of fields of the store, then it will wire it through on behalf of the user, even if the input does not correspond to any of the registered schemas. So just a quality of life improvement. So that's it for the write APIs. These are the things we added in the past year. Now, switching gears, the read APIs, how do we get data out of Venice? We've done some work there as well in the user-facing side. Here, I will call out some of the APIs I present are experimental, whereas the write APIs I just presented, they're I would say they're pretty likely to remain exactly as they are, but for some of the read stuff, some of them we're still playing around with it. We might still tweak it. And so if you see the experimental annotation on one of these interfaces, know that it's kind of a preview feature, right? So this is just a recap of the last talk. These are the three main clients for reading data: thin client, fast client, DaVinci client. The first two are stateless. The third one is stateful. I'm not going to go over that again, but let's talk about the fast client, right? So fast client has been running in production for a couple of years now, maybe even 3 years. I don't know, 2 or 3 years. But up to now, we supported only the single get operation. Now we've built support for the rest of the reading client APIs. So that means the batch get and the read compute. I'm skipping over because there are more things going on in fast client, but Shun will talk about it in the last talk of the day. In terms of DaVinci, there's a little bit of changes to the API surface. We have removed an API called non-local access policy. This is a configuration of the DaVinci client, which has been there from the start, but which we have not seen in the past 4 years that DaVinci has been in production. 5 years even, that DaVinci has been in production. We have not seen yet a valid use case for that config. And we have seen cases where there were some outages from users misunderstanding what that config was about and then kind of using it wrong. So we felt it's just not worth having that complexity in the API. So we're kind of taking a lesson learned here and deleting that one. We have added, however, a couple of experimental configs to the DaVinci client. One of them is the record transformer. That one allows you to plug in a custom hook where you can process all of the records ingested by DaVinci and do something with them, right? So you can, for example, choose to filter the record. based on whatever content is in it, or you can choose to transform it. If you transform it, you have to always transform it into the same schema, but it can be a different schema than the schema of the store. So for example, you could use that to project just a subset of the columns if you'd like, or compute like whole new columns, out of whole cloth. And we think there's a lot of potential here. We're still iterating on that, but we'd love to get feedback if anybody has any about this functionality. And then we have one more API, which is a bit more straightforward, which is to speed up very large batch gets on the DaVinci client. If you have CPU to spare, then with this config, you can split the large batch get across many threads and run it in parallel. Whereas by default, the batch get will be executed sequentially, one key at a time. So this is the large batch get request split threshold. Now, one more read API that we're adding is, in addition to having a producer style API, we now also have a consumer API. Now, this one is very experimental. We are starting to use it. It is used in production today, but we're still iterating rapidly on what is the correct shape and functionality set of this API. So definitely treat it as a preview feature. It should be noted also that there is a little bit of overlap in the scope of capability between Consumer API and the DaVinci Record Transformer, because both of them can do arbitrary processing on all of the records in the store. By the way, I'll mention here that there will be a blog post version of this talk that I'll publish maybe later today or tomorrow, where I go in a bit more details about the nuances between the Consumer API and DaVinci Record Transformer. So if you're interested, you can read that also. But the gist of it is this Consumer API enables change capture use cases, right? So if you need to hook up to the Venice data and do something with it, put it elsewhere, or update some other system out of it, now there is a client for doing that. Okay, switching gears, my last section is kind of operator centric. Like I said, what are the operational improvements we did to the system? There's a lot that goes in there. Actually, a very large part of our efforts goes into improving the operations of the system to keep up with the scale increases that Zach was talking about earlier. And so I'm going to talk about a few themes. The first one being, what did we do in the push job, right? So for a long time, we've had use cases that are in the time to live category, right? People want to keep ephemeral data inside of Venice. We used to support TTL use cases with a pattern that we call empty push, which is essentially a hybrid store where when the full push comes in, that full push is empty. Its purpose is just to create a new empty snapshot. And then we leverage the hybrid store's real-time buffer rewind capability to replay the last, n number of days of data or n hours, whatever the case may be. And that is the design pattern that we recommended users pick if they only want ephemeral data in Venice. That worked. We have I think many dozens of use cases that have been running like that in production. It's just not the most efficient. So we have a new approach, which we intend to fully replace the empty push pattern with. The new approach is called TTL repush. Essentially, it performs more of the work inside of the grid so that the data being pushed is resorted, you could say compacted, and certain kind of housekeeping, is done on the data set so that it's faster to ingest in the Venice servers, and it also speeds up other maintenance operations. Like if the servers need to rebalance, for example, a store that has received TTL repush is faster to rebalance than a store that's been receiving the empty push style of TTL. So kind of an efficiency improvement. Eventually, we might. I don't know if we'll get rid of empty push completely or if there will still be a need for it, but eventually we intend to run all TTL use cases with this TTL repush. And we have been using it in production already. The next one that Manu alluded to earlier is we have rewritten parts of the push job to run not only on MapReduce, but also on Spark. So now it supports both. Eventually, we will probably fully deprecate the MapReduce path, but I don't know when that would be. For now, it supports both. We have already been running the Spark mode in production. This modernizes our stack, gives us kind of fresher dependencies because MapReduce is not like that regularly maintained anymore by the community. And it also enables us to get better connectivity for new input formats that are coming out, like Iceberg and stuff like that. And that being said, the Spark mode is not quite at performance parity with the MapReduce mode. This is something we're still iterating on, and we do intend to bring it to parity. So that is that. One more thing we did is we have a mode where the push job can gather compression statistics on all jobs, even if compression is not enabled for that store, right? And what that enables us to do is we gather these heuristics on the compressibility of all the stores, and then we can mine those heuristics to periodically decide how to fine-tune the system, right? So we can discover some stores which have very high compressibility ratio, and then go save like many terabytes of SSD or possibly RAM by turning on compression. And as was mentioned in the previous talk, this is kind of a invisible infra philosophy where we can turn on compression without the user needing to be involved, needing to configure anything on their side. It just happens like automatically under the hood. So that's that. Now, another category of improvements we did is to the server ingestion. So this is sort of the beating heart of Venice, possibly the most sophisticated and most complex code is the server ingestion. This is also a part of that, at least, is the same code that runs inside the DaVinci client library as well. So the ingestion code gets a lot of our attention. One of the things we did here is in terms of pub/sub. Well, I already said on the user-facing side, we now have a producer client and a consumer client, but under the hood as well, there is kind of a pub/sub story unfolding, which is that we now support plugging in another pub/sub than Kafka. For now, in open source, we support only Kafka, but there has been some interest from the community to support, let's say, Pulsar instead. Stuff like that should become easier and possible with this. Now, for the time being, the pub/sub system that replaces Kafka must still support log compaction, and it must still have numeric offsets. But these are two things two constraints that we are probably going to loosen up in the future. So it should be possible in the future to replace Kafka with a pub/sub system that doesn't even support log compaction or that has non-numeric offset. For example, Pulsar has non-numeric offsets. Another thing we did is we introduced heartbeats. This is something where the leader replica of each partition writes a heartbeat once per minute into that partition, right? And this allows us to get more reliable time lag measurement, right, for all of our write paths. Now, we used to have some lag measurement capability before, but it was kind of flaky. It didn't always work. And there were edge cases where, like, well, what if the workload has low throughput or has like infrequent writes, like once a day it wakes up and writes a bunch and then stops or whatever. We couldn't necessarily disambiguate the silence from the outage, right? So with this we can, and now we're investing quite a bit in making sure our write path has a deterministic tight SLA. Although some of that work is still in progress, but there's a big piece of it that already went into this release. We also invested in workload isolation, and this is something we intend to continue investing in. Essentially, the thing here is we have different types of write workloads coming into Venice. We have batch workloads, which are, although they're high volume, they're actually quite optimized, very efficient. They get like sorted offline and so on, and so we can trigger like a bunch of optimizations when we take them in. Whereas the update path has a very high cost, right? Because the server is needing to merge the existing data with the incoming data. It needs to do conflict resolution and stuff like that. And so the leader real-time processing, it turns out, which is where the update code is located, is way more expensive. And so now we have the ability to split that into a separate processing pool, and that has allowed us to better isolate the workloads between the batch stuff and the real-time stuff. And in the future, we plan to further enhance this isolation by having the ability to prioritize writes into the current version and let the backup and future dataset versions sort of take whatever's left. And then further enhance our ability to meet tight write latency SLAs thanks to that. We have a few API deprecations that are planned. In the release that I mentioned, those functionalities are still there, but in the next release, they almost certainly will not be anymore. So the first one is ingestion isolation. This is a functionality where we can fork off a child process to take care of the batch ingestion, while the parent process or main process takes care of the read path and real-time ingestion. So we had this ingestion isolation mode for both the DaVinci client and for servers, and we've run both of those in production. But it turns out that the server mode of ingestion isolation is quite complex, very burdensome in terms of maintenance. And we did some extensive benchmarking on it and concluded that it wasn't worth it from a performance standpoint. For the types of workloads that the server needs to support, it wasn't bringing significant enough benefits to have this multi-process architecture. We are still keeping it for now for the DaVinci client, where the diversity of workloads in the host application is much greater, much more diverse. And so it seems more prudent to still have this separate process isolation there. But for the server, we concluded it's not worth the maintenance hassle. So that's one API that is getting deprecated. And another one is called amplification factor. This is one where the real-time buffer topic could be partitioned to a different partition count than the version topic. Kind of a obscure thing, but essentially we thought this would improve scalability in some cases. It turns out this one was also quite burdensome to maintain, and we haven't really found a use case that absolutely needed to have that. So we're reducing tech debt and kind of deleting that as well to help us progress better in future development. So that's just an FYI. And if you want to learn more, we've got our documentation at venicedb.org. We've got the blog. We've got the open source Slack that you're welcome to join. Like Zach mentioned, we also have a contributor sync up every 2 weeks on the Wednesday morning. Next one is tomorrow if you want to join. And on the blog, there will be a blog version of this talk summarizing all of the delta of changes between the last stable release a year ago and this one. And in some cases, going into slightly more details than the talk. And well, in the future, we'll try to come out with these stable release announcements more often. We're not committing yet to a specific timeline, but it should be more often than once a year, I guess. And the delta of changes should be smaller each time. So that's that, and that's all I had.